So GPS is being used worldwide for position navigation and timing solutions. The system has been operational since the 1980s for civil sector, but there is currently no encryption on these signals and the structure is openly known.
With the advent of readily available cheaper hardware and software, it is now more than ever to replicate GPS signals. Thus, a bad actor, whom we refer to as spoofer, can broadcast a false GPS signal with the higher power to any user utilizing GPS. The spoofer can then deviate the user along a dangerous trajectory, and for applications like aircraft landing, this is a huge safety of life issue.
We have come up with a novel technology here at Carnations where we leverage an already existing sensor which is called the inertial measurement unit to detect spoofing. The redundancy of this sensor is what helps us with spoofing at a very early stage and even the most covert type of spoofing. The novelty of this solution is that it can detect spoofing even if the spoofer is able to closely replicate the authentic signals. This has actually led us to file the first patent application for our technology, which is being filed currently by Illinois Tech. So in order to validate the solution or the technology that we have, we typically test the system in our lab here. So what we do is we try to replicate the spoofing scenario, have some of the hardware that we have here to see if we can detect spoofing in our technology. So what we have here is a GNSS simulator, and what this hardware software device allows us is to simulate live GNSS signals. For example, if you simulate a spoofing scenario here, it will send those signals to this USRP. The USRP then converts those signals into live radio frequency signals, the same as GNSS signals that the receiver would see outside from the satellites. What this allows us to do is to test different spoofing scenarios, and the prototype that we have here takes those GNSS signals and detects if there's spoofing going on or not.